Welcome back, everybody. Looking at winter 2017, we have a question on, I would think it's part 4, question 7, or maybe, I think it's just her 7th question on this document. But she said it was from winter 17, and I trust her. Both of these groups on these phenols are ortho-para directors. So para being major and ortho being minor. Which one is going to help cations better? A carbon with electronegative fluorines, which makes this carbon feel pretty positive. Do you think a positive here is going to stabilize positive here? No, it destabilizes. The fact that it can hyperconjugate does stabilize, but the fact that these carbons are very positive means it's not as good a choice as a carbon that isn't very positive. So I'm going to answer her question thusly. This is a stronger ortho-para activator here. Stronger OP because C is not C delta plus. This C is definitely C delta plus, which destabilizes cations over here. So your major product will be para here, and the minor will be ortho on the same ring. So major, and it's terrible drawing there. Play my cards right, I can copy paste. There, that. Seems like I'm missing a tool. There, it moved. I moved it somehow. And the minor is down here. We're putting a bromine on. Para, major, ortho, minor. That ortho is fine. Oh, wow. Doesn't like control Y. It's doing weird things on me. Probably my fault. Bromine here for para. Bromine here for ortho is the same as bromine here for ortho. It doesn't matter which one you pick. And that's it. And let's see. I hope I explained to her liking why I like the ring on the left. And when you count on the ortho-para, you have to count how many carbons far from the CF2. Yeah, I think I answered that here. Ortho is on the adjacent carbon, so only 1 away from the CH2F. Meta is 2 away, and para is 3 away. So I don't know about what she's trying to say here. 2 for ortho. Position 2? Okay. In which case, this would be incorrect here. That'd be position 4 on benzene is para. And our numberings would go 1, 1, 2, 3, 4, or 1, 2, 3. Oops, I was inconsistent there. 1 is where the group is. 2 is the ortho position. 3 is the meta position. 4 is the para position. And I think we got that covered. And wow, there we are. And apparently I didn't put a page on an answer key for winter 2019, and it's missing. And acid-base stuff back, come full circle. Let's get this a little bigger. All right, question being now, what is closest value of pKeq for the reaction that makes molecule X? Once again, we like the imidazole better than the pyridine, and aniline is the worst. So we like which of the two carbons in imidazole? Please don't use the one where she drew the lone pair. You need that for aromaticity over here. Don't put the H there. Put the H right here. And molecule X would not be this. Oh, she's right. I didn't even notice this guy over here. So I have a choice of, well, how many nitrogens? 1, 2, 3, 4, 5. Let's categorize them all. Aniline, worst. Pyridine, in this molecule, second worst. Imidazole, second best. Aliphatic tertiary amine. She correctly identified that as the best place to put the H on this nitrogen. And she drew it here, and that was nice. Check. And the pKa there is 10. Aliphatic amines, that's the one we learned way back in chapter 4. We didn't even know what aliphatic meant. Saturated hydrocarbons, in case you still don't know. pKa is 10. So we're making a 10 from NaHCO3. She correctly identified as pKa 11. So 11 minus 10 equals -1. And that is pKeq. And she just picked the wrong number. No, that's sad. Why is my... That's weird. All right. Yeah. It's always, this is a reactant. This is a product. You do the reactants pKa minus the products pKa. You don't use this molecule because it's a base, and you don't use CO3 2 negative because it's, here's the other product, by the way, CO3 2 negative. You don't use that because it's a base also. All right, and moving on to pKeq for the reaction indicates molecule Y. So it's not about the 10 anymore. It's about, I should reverse the order of these. Which one's Y? Well, what's our next best position? Best was here. We've already done it. Next best is the imidazole. So, and I want you to use this N. I hope she did that one. And she did. Nice. She nailed it. She used the imidazole sp2 nitrogen. And imidazole has a pKa of 7. So what's the acid up there on the left? This is the acid that's in the products. The acid that's in the reactants, let's see, what are we doing? It's here. H2CO3, she correctly identified it as 6. So we're talking about 6 minus 7. Once again, reactant acid, H2CO3. Product acid, 7. 6 minus 7, -1. And she got that one correct. And pKeq for Z. All right, let's look at what's our next best H. Hey, why don't we look at this? Because now we're this. Where are we at? Wow, I'm losing my mind. Here we are. This is the reactant that needs to pick up another proton. Okay, you're down to an aniline. Don't do the aniline. And a pyridine. Do the pyridine. Pyridine picks up a proton. Don't say that 3 times fast. And she correctly identified pyridine picking up the proton. This one stays the same. This one stays the same. And you just need to remember, pyridine, when it has a proton, is a little more acidic than an imidazole with a proton. And that's all I need to memorize, and that'll get you close. Just remember, they're not too far from each other. So the pKa here is a little lower than this because pyridine itself was not as good a base, right? Remember when pKa goes down, then pKa for the conjugate acid goes up, up. All right, so you're going to make an acid with a pKa roughly 6. Okay, and the reactant, that's the product acid. That's this molecule here. The reactant is now HOAC. She correctly identified with a pKa of 5. Correct. So 5 is going towards our 6. It's a -1 fest. Yeah. I think every pKeq is -1. I don't think that was my original intention. It just worked out that way. And the closest of all these answers to -1 is the 0. It's not, I mean, you got an argument for here, but you're 2 away from that one and you're 1 away from that. And it's worse than that. It's powers of 10, right? You're only 10 to the power of 1 away from this answer, and 10 to the power of 2 is 100 away from this answer. I believe we finished the whole page. Yeah. So it's a nice page. I wouldn't this is a COVID exam, so I'd cut it in half. Won't have 3 steps, probably 2. And there's good questions here. All of them. I love them. And PKB for amines is critical on this test. You've seen many questions. All right, so I'll look forward to more questions by email or live for this afternoon's 3:30 session. And if I see you, I see you. If not, I know you're studying away diligently, being good students. And take care.